about combinations. Combination is a selection of objects where order does not matter. So let's say 3 of you were getting a prize. But the prize was one of these. Does it matter what order I call you up in?
No.
No, because you're all getting the same thing. Order doesn't matter.
Well, maybe one doesn't.
Okay. Order doesn't matter. All right, so let's. This is the formula here for combinations. The number of combinations of n objects taken r at a time is this. How is this, other than the c, different than the other equation?
Because on the bottom, after you minus w.
You've got this r here, right? Yeah, so this has been added on for combinations because we don't need so many. Order doesn't matter. Let's see an example of that here. Count the combinations of 2 letters from this list, A, B, C, and D and E. So I'm going to start, we're going to write them all out this time. So we're going to say, okay, A and B, A and C, A and D, A and E. Then we go to B. B could go with A, B could go with C, D, or E. Then we go to C. C could go to A. You see where we're going with this. We're going to list them all out. Then we go to D, DB, DC, DE. And then last we do E. EA, EB, EC, and ED. Now, combinations means that order doesn't matter. So we have to knock off the duplicates. So AB is here, it's also here. I don't need to count that one. We're not counting duplicates, we're not counting order. Okay? AC is here, it's also here. I got to knock that one off. AD, we got to knock that one off. AE, we got to knock that one off. Because we're not counting order, it doesn't matter. We only want to just know how many combinations we can get. All right, BC, there's another BC right there. BD, there's another BD. BE, there's another BE. CD, there's another DC. CE, here's another EC, CE. And then DE, there's another one. So we actually cut off how many?
Half.
Half of them. So we have 10. We have 10 possible combinations of 2 letters. This is going to be a smaller number than permutations. If ordered mattered, how many would we have if order mattered? All of these, right? Which is how many? 30. Oh, actually, is there 20 here? Yeah, there's 20, sorry. 20 if order mattered. But it doesn't. That's why it's going to be a smaller number. Okay? All right, let's do a little bit more on the back side. So, you can choose 2 courses out of a list of 6. How many combinations of electives are possible? When you see this word, okay, order doesn't matter. When you see that word combination, order doesn't matter. So let's use the formula this time. I have 6 courses. I need to choose 2. How many combinations of 2 courses can I get out of 6? So I'm going to plug it into the formula. 6 factorial. Top is the same as yesterday's. You still do 6 minus 2 factorial. But then you also add on an r factorial, which is 2 factorial. That's a multiply, actually, it's not add. Okay, let's simplify this. 6 factorial, 4 factorial times 2 factorial. Please, please, please do not confuse this on the bottom as 6 factorial, because it's not. It's 4 times 3 times 2 times 1 times 2 times 1. Okay? Now, at this point, you can plug it in the calculator. I'll just tell you what it is. And you get 15 possible combinations of 2 electives out of 6. Meaning you could take art and gym, or art and graphic arts, or art and whatever. See, there's lots of different combinations. Now, can you just put this on the calculator as well? Did anybody see it? It's on the same page as permutations. Turn on your calculator, push the math button, and go to probability. There it is, right there. Okay? 6, you put the 6 in, then you push that, and then you put the 2 in, and you get 15.
Would you get a different answer if you did it for the NTR?
Yeah, there's a lot more if order did matter. Because like you might have to have art first and then
Okay.
graphic arts, and then, or you could have graphics first and art second. So those are 2 different options. When order doesn't matter, it narrows down to 1. Okay? All right. Your teacher randomly chooses 2 out of 8 students to give an impromptu debate on freedom of press in high school newspapers. What is the probability that your teacher chooses you and your best friend? Out of 18 students, there's quite a few combinations of 2 students. So, in order to find probability, we have to figure out the number of combinations first. Okay? So, find the total number of combinations of 2 students at a time. So we're going to use the formula. 18, choose 2. Out of 18 students, how many groups of 2 can I get? Plug it into the formula. Put this on the calculator, or put this on the calculator, you'll get the same answer. You get 153. 153 ways you could combine 2 people out of 18. It's crazy, isn't it? Seems like a lot. Okay, if there's 153 ways to put 2 people together, what's the chance that your teacher is going to put you and your friend together? 1 out of what? Because you're only one of those combinations. You and your friend are only one of those combinations. All right, last one. You can order 1 of 3 sandwiches at a restaurant. And you can choose 2 side dishes out of a list of 8. How many combinations of meals are possible? So first, we're going to consider the sandwiches. You have 3, you're going to choose 1. Then the sides. How many sides can you choose from? 8. You get to choose 2. When you have 2 different situations here, you multiply your answers together to get the final number. So think about this one. If you have 3 sandwiches, you get to choose 1. How many options are there? 3, right? 3 choose 1 is just 3. 8 choose 2, I went to the calculator, it's 28. When you multiply them together, you get 84. There's 84 different meals you could put together. So combinations isn't too bad. Here's what you get to do over the weekend. Number 1, 4 through 7, 14 through 19. It's pretty quick. Factorial is on your iPhone calculators. I saw it.